3 sections, we're going to fill in our other formulas that we have on here. So we have our sum and difference and double angle formulas that we will get through. So today I am going to start in our notes for a moment. I just wanted to refresh something. So spiraling back to something that we talked about, but we had a little bit of trouble remembering it at the time. Not that it was complicated, but remembering what things were. So remember co-function. It has the word co in front of it. So what is the co-function for sine? Cosine. Remember, this is different than the reciprocals. So the co-function for sine is cosine. Sine goes with cosine. Tangent would go with. Secant would go with. And the trick with these is they are equal when the angles are what? That means if the angles add up to 90, these are the same, which we've seen, like on our hand trick. The sine of 30 degrees and the cosine of 60 degrees are the same thing. Sine of 45 and cosine of 45 are the same. So if I said the sine of 34 degrees, that would be equal to the cosine of what? 56 degrees, just 90 minus 34. The secant of 18 degrees would be equal to the all right, so you guys, that came back faster than I thought it might. So we remember co-functions? Okay. So the next piece, what's getting us through today and tomorrow, I have a question for you. You can write this down if you want, you don't have to. Is it true? Cosine of A plus B equals cosine of A plus cosine B. So let's think of it with an A and B that we know on our hand trick. If I said the cosine of 30 degrees plus 60 degrees, is that equal to the cosine of 30 plus the cosine of 60? That's what I need to know. If I do 30 plus 60, that gives me 90. Cosine of 90, remember our hand trick? Hope so, it's not going away. We haven't used it in a while, but it's coming back. We're going to start using it a lot again. So cosine is the square root of the bottom over 2. How many fingers do I have below the one I folded? 0. So cosine of 90 is just 0. What's the cosine of 30? What's the cosine of 60? 1 over 2 is a half. Is 0 equal to the radical 3 over 2 plus 1/2? No. So these are not equal. So if you have a cosine of 2 things added together, you can't distribute the cosine to each of them. That's why we have special sum and difference formulas. So that's what we're going to write down next. If you're really interested, I could show you where these formulas come from. I could derive them and prove them for you. Most people don't usually care. But if you want to see it, I can prove it to you. I'm not just lying and making it up. It actually does work. We will have a total of 6 of these on this page. So we'll do sine tomorrow and tangent tomorrow. Today we're just doing cosine. So write this on your flip chart. Flip to the sine and difference formulas page. And we have 2 formulas for cosine of a sum or cosine of a difference.
Is this all that's going on?
There will be 4 more tomorrow. So a total. So let's look at a problem. If I ask you to find the exact value of something, that means with radicals. If I type the cosine of 75 degrees in my calculator, it's going to give me a decimal. That is not the exact value. But obviously we can't memorize a hand trick for every possible angle, right? 75 is special. We can still find the exact value by using angles that we do know. So think about our unit circle. All those angles that we have on there. Are there two angles that would add or subtract to give us 75? Okay, I could do 30 plus 45. Now, some of these there might be multiple ways. Like we could have subtracted two angles to get 75. That's okay, you just have to have an equivalent one. So when I look at this, I notice that I have a plus sign in the middle. So out of the two formulas we just wrote down, which one are we using? The first one. So that formula says cosine of A is just my first angle, B is just my second one. So it's the cosine of 30 degrees, cosine of B, so cosine of 45 degrees, minus sine of A, sine of 30 degrees, sine of B. So because my sine was a sum, I went with the A plus B formula. I know A and B, 30 and 45 degrees, and I plug those in. Now we can evaluate. So think about your hand trick. Cosine of 30, so that would be times the cosine of 45. So my hand trick, square root of the bottom over 2. Radical 2 over 2. Minus sine of 30. Sine is the square root of the top over 2, so radical 1 over 2 is 1/2. Sine of 45, so radical 2 over 2. So when I multiply these, we multiply the tops. Square root of 3 times the square root of 2 is the square root of 6. Over the bottom. 2 times 2 is 4, minus 1 times the square root of 2 is the square root of 2, 2 times 2 is 4. That is my answer. You are welcome to, if you want, they have a common denominator, so you could make one big fraction, but you can't actually do the square root of 6 minus the square root of 2 without getting it done. So exact value means with the radicals, so we have to use the formula to break it up. Any questions on that? I don't know about you, maybe it's just me, but it is a whole lot easier for me to think about degrees being added together than it is radians. Like pi over 6 plus pi over 4, like what's going to add to give me this? That's hard for me. So what could I do with this instead? How do we convert that into degrees? Okay, so if we do that, gives me 255 degrees. And that's always where I start if I'm given radians. I think it is way easier to think about adding and subtracting whole numbers than it is fractions. So that's what I do first. Now I need to think about my unit circle. Okay, I'm not going to be able to get there just using 30, 45, and 60, are we? Do you have an idea, Keegan?
Cosine of 210 degrees minus 15 degrees.
But 15 isn't on our circle, is it? So, right idea. Let's look for some bigger angles. Do you guys have a blank circle, or not a blank one that's filled out you could pull out and look at? Look at some of our angles or stare up at the ceiling. Can we find 2 degrees that would either add or subtract to give us 255? Okay, I've heard several. Okay, I heard yours first. If we did does 315 minus 60 equal 255? Definitely not the only place to get there. I was thinking 120 plus 135. Okay, Cameron had another one. So there's lots of them that could get us there. All right, you just have to find one that works. Now, when I look at this, the option I picked is a minus. So which of my formulas do we use? Second one. So that formula says cosine of A, what's my A value?
315.
Cosine of B. My B is not negative 60. The negative is because I'm using the subtraction formula. So it's just cosine of A, cosine of B, plus sine of A, sine of B. Does everyone understand how I know which of the two formulas to use? And how I know what A and B are? Okay, so now we evaluate. 315, all right. Oh, this is good review for us. What quadrant is that? What's my reference angle? Remember, that's distance to the x-axis. 360 minus 315 is 45. In quadrant 4, is cosine positive or negative? Positive. Remember, all students take calculus. Quadrant 4, cosine is positive. Cosine of 45, radical 2 over 2. Cosine of 60, 60 is in quadrant 1. We know it's positive, square root of the bottom over 2 is 1/2. Plus sine of 315. We already know it's quadrant 4. In quadrant 4, is sine positive or negative? And the sine of 45 degrees? And the sine of 60 degrees. So that's bringing back all of our quadrants, reference angle, hand trick. Are you guys okay with that? Now we just multiply. So radical 2 times 1 is radical 2 over 2 times 2 is 4. Plus a negative, or you could write minus, radical 6 over 4. You could put them as one fraction as you want, if you wanted, or just leave them like that. They're all going to be pretty similar answers, like involving radical 2's and radical 6's, because we're using the same reference angles, right? On my hand trick, we only had 1/2 radical 2 over 2 and radical 3 over 2. So we're using combinations of those things. All right, questions on that one? What if I give you this one? What have I just given you? The formula. I gave you the right-hand side of the formula. Okay, when you see cosine, cosine plus sine, sine, that's the cosine of what? Right. So my A is just the first angle, 173, minus B, my second angle, 83. 173 minus 83? 90. What's the cosine of 90? 0. Use our hand trick. So most of the time, we're filling in the right-hand side of the formula, but we could work backwards as well. All right, that's the new piece for today. Any questions so far? I want to keep practicing some proofs as we go through this stuff, so we're not getting rusty on that. So let's try one of those. Which side would you box in?
The right side?
Yeah, I agree. So we have the cosine of x plus 2 pi. What would we do? Can we just distribute the cosine? No, that's what our formulas are telling us, right? So this is just saying we have like cosine of a plus b. So we go to the formula. What's the cosine of a plus b formula? 2 pi, if you think about your circle, 2 pi is all the way back around, right? It's the same as 0. So I have cosine of x times, what is the cosine of 0? 1. Radical 4 over 2 is, or if you think about it on the unit circle, this is 0.10, cosine is the x. Minus sine of x times, what's the sine of 2 pi, or the sine of 0? So I just have cosine of x minus 0, or cosine of x. Is that okay? Got just a couple more examples. I'm asking for a single function, so I'm not getting a number answered here. What I'm wanting you to recognize is you have cosine cosine minus sine times sine. What's that the formula for? So what's my A? And my B? So that's just the cosine of 5x. That's all we can do to simplify. So one more proof. Which side did you box in?
The right side.
Do I have a difference formula for secant? No, so what would I have to do?
Turn it into cosine.
Secant is 1 over cosine. So then we can do the cosine difference formula. So cosine of A, cosine of B, plus sine of A, sine of B. Think about your unit circle for a second. Where's 270? Down here. What's that ordered pair? So the cosine of 3 pi over 2, cosine is our x, is 0. Sine of 3 pi over 2 is -1. So we have 0 minus sine x, so 1 over negative sine x, and so we have the opposite of, what's the reciprocal of sine? Any questions? Okay. So handback quizzes in a moment. The homework for this. If you go to Classroom, I moved that Chapter 5 assignment post back up to the top. So we are on section 5.3. I think think it's 10 questions maybe. But some of the most commonly missed questions on this were the last few. I don't know if this one looked familiar to you. It was actually on a homework assignment a little bit ago. Most people boxed in this side, but here's where some of you made it way hard. You were trying to get common denominators, and you had secants and cosecants, and you can get there from that, but it got pretty ugly, and a few of you just kind of gave up in the middle because it got nasty. If you change the sines and cosines from the beginning, what is secant? What is cosecant? How do you divide fraction and a fraction? Are you guys with me there? So then if I multiply those, what's that? 1. Some of you from there said that you remembered it was equal to the other identity, the tangent squared plus 1 equals secant squared. Some people boxed in this side and had to come over here because they couldn't remember how they were related, which is fine. If you did that, secant is 1 over cosine. Tangent is sine squared over cosine squared. They have a common denominator. What is 1 minus sine squared? Gave you 1. So that was perhaps an easier approach than some of you had tried. Are there, on C, what strategy did you need to do there? We need to get a common denominator, which really involves multiplying by 1 plus sign on the first fraction and 1 minus sign on the second fraction. So I'll come around and see if you guys have individual questions over these, so you can work on your homework, and